talk about the standard form of an equation of a line. First, I'm going to define that, and we say the standard form of an equation of a line, another way of saying this is a linear equation in two variables. So here we have two variables, we'll call them x and y, is an equation that can be written in this form. ax plus by equals c. Here a, b, and c are constants. And if we have it written in this way, we have a line and it's in standard form. Okay, now there are other forms for the equation of a line that will help us with graphing and such, but this is the one that we call standard form. Alright, so I'm going to show you some examples. Let's figure out, are these equations really linear equations, and can we get them in standard form? Alright, so here we are. Are the following equations linear? Alright, so for part A, we have 2y minus quantity x plus y equals y plus 1. At first you might want to say, well, that's not ax plus by equals c. But the thing is, I think we can write it that way, so let's try it. Okay, so first of all, I'm going to go ahead and bring this y over to the other side. So I have 2y minus y gives me 1y. I'm going to distribute that negative equals 1. And then y minus y cancel out, so end up with negative x equals 1. Okay, is this linear? Yes. Okay, it doesn't look like it's in standard form, but I could write it as negative 1x plus 0y equals 1. As long as the coefficients in front of x and y are not both 0, that counts. This is linear. Okay, part B. I have x minus 3 over 2 equals 4 plus y over 5. This is fractions, so surely it's not linear, right? Actually, this is linear. Okay, so I'm going to simplify this equation by doing this. I'm going to multiply 2 times 5 on both sides of my equation. Okay. When I do that, on the left-hand side of the equation, the 2 cancels out, and on the right-hand side of my equation, the 5 cancels out. Okay, so what I'm left with then is I distribute my 5 in the numerator on the left-hand side. I have 5x minus 15 equals 8 plus 2y. Now I'm going to get everything that's not constant on one side and everything that is constant on the other. So I'm going to add 15 to both sides, so 8 plus 15 is 23, and subtracting the 2y over, I have 5x minus 2y, and that is definitely standard form. So is this linear? Yes, this is also linear. Okay, now moving on to question C, we have x squared minus xy equals 15x minus y. I don't have to do any real work here. I know this is not linear. How do I know? That's a big tip, x squared. But sometimes the x squareds can cancel out. But notice in this equation it can't. Alright, also the xy is a big tip. X times y, that's a degree 2 term. So this is not a linear equation. Okay, now moving on to part D. No, this is not linear either. Why? For the same reason. X times y, that's a degree 2 term. Linear equations, we need degree 1 terms. It's supposed to be ax plus by equals c, and not x times y. That doesn't work. Okay, so I hope this helps. This is kind of an introduction to linear equations that we can graph, and I'm going to show you how to graph those soon. If you have any questions on them, please let me know, and thanks for watching.